Hello everyone, welcome to my YouTube channel. This is Sachin, and today we are discussing about insertion sort and quick sort algorithm. So let's start. First of all, we must know what is insertion sort. Insertion sort is one of the simplest algorithm for the reason that it sort a single element at a particular instance. Okay, right? It is not the best sorting algorithm in terms of performance, but it's slightly more efficient than selection sort and bubble sort in practical scenarios. Okay, right? Got it? It is an intuitive sorting technique. Okay. Now next, here's the implementation of insertion sort. For j is equals to 2 to a dot length, key is equals to a of j. Now you can see the code implementation of insertion sort. Okay, right? Next, consider the following example of an unsorted array that we will sort with the help of the insertion sort algorithm. Now we consider the example of unsorted array. Here's the unsorted array. A is equals to 41, 22, 63, 14, 55 and 36. Here's the unsorted array, and we sort the array in ascending form. Okay, right, initially. So let's take an example and solve it with the help of insertion sort. So we solve the example in iteration form. So here's the first iteration in insertion sort. First iteration, here's the unsorted array is here, and we set the key 22. Now here's the indexing of array. We all know the indexing of array will start from 0. Okay, so here's the a0, a1, a2, a3, a4 and a5. Okay, right? So we will compare a1 with a0, means 22 को कंपेयर करेंगे 41 से. ओके, तो कंपेयर करेंगे सिंस a1 with a0, since a0 is greater than a1, a0 is greater than a1, so swap both of them. If a0 is less than a1, then there is no need to swap any element of array. Okay, but there is 41 is big than 22, since a0 is greater than a1, so we need to swap both of them. Okay, now you can see the result after swapping 22 here and 41 here, and keep this array as it is. Okay, 63, 14, 55 and 36. Okay, now we go for second iteration. Here's the second iteration, and there is a key 63. We set the key 63 and compare a2 with a1 and a0. Here's the a2 and a1 and a0. a2 compare with a1 and a0. So now we compare, since a2 is greater than a1 and a1 is greater than a0. Okay, so a2 is greater than a1 and a0, sorry, a2 is greater than a1 and a0, and a1 is also greater than a0, so there is no need to swapping. Okay, there is no need to swap any element of an array. So now we keep the array as it is. Now we can see the result: 22, 41, 63, 14, 55 and 36. If there is a2, if their a2 is less than a1, then we need to swap the element of a2 and a1. Okay, now we go for third iteration. Here, set the key 14. We set the key 14 here. Okay, and compare a3 with a2, a1 and a0. Here's the a3, 14. We compare with all three elements from the left side of an array, from the left side of key 63, 41 and 22. Here's the a3, compare with a2, a1 and a0. So now compare, since a3 is the smallest among all the three elements on the left hand side, place a3 at the beginning of the array. Now you can see here the 14 is the smallest number in this array. So now we take we place place this element in the beginning of an array. Now you can see the 14 in the beginning of array. Now whole array is as it is. Okay, 22, 41, 63, 55 and 36. Okay, now next for fourth iteration. In fourth iteration we set the key, next key 55 एंड 55 को कंपेयर करेंगे बाकी के एलिमेंट से, ठीक है. नाउ यू कैन सी कंपेयर A4 with A3, A2, A1 and A0. Okay, all the 4 elements from the left side of key which compare with. Okay, as A4 is less than A3, A4 is less than A3, then swap both of them. A4 is greater than A2, A1 and A0, but less than in A3. So now we compare only these two elements. Okay, these two elements A4 and A3. Now you can see the result after swapping 14, 22, 41. Then swapping both elements 55 and 63 here and 36 as it is. Okay, now got it. Next iteration, fifth iteration. Fifth iteration, last element, array of last elements, we set the key 36. Okay, and we compare all the elements of the left hand side. Okay, here's the, you can see A5 with, compare A5 with A4, A3, A2, A1 and A0. now you can see here. Okay, compare कर रहे हैं हम सभी से. Since A5 is less than A2, since A5 is less than A2, A5 is less than A2 and A3 and A5 but is greater than A1. Okay, so we will place the element in their correct position. Okay, so here's the correct position here. Now you can see the result after swapping 14, 22 and 36 here, and 41, 55 and 63 here. Here's the our array is sorted in ascending order. Okay, we sort the array with the help of insertion sort, hence the array is arranged in ascending order, so no more swapping is required. Okay, yeah, there is no more swapping is required because our array is sorted in ascending order. Okay, now next, complexity of insertion sort, complexity analysis of insertion sort. Okay, now we give the input, given an input element. Okay, now output number of step incurred to sort a list. Logic, what logic we apply? If we are given an element, then in the first pass it will make n-1 comparisons, in the second pass it will do n-2, in the third pass it will do n-3 and so on. Okay, thus the total number of comparisons can be found by, okay, output n-1 plus n-2 plus n-3 and so on, n-4 and so on plus 1. Okay, there is a sum. Here's the our unsorted array 41, 22, 63, 14, 55 and 36. Okay, time complexity of insertion sort is order of n square, and space complexity of insertion sort is order of 1. Therefore the insertion sort algorithm encompasses a time complexity of order of n square and the space complexity of order of 1, because it is necessitates some extra memory space for a key variable to perform swaps. Okay, got it. Here's the our insertion sort is complete. Now we will go for quick sort. Now here's the quick sort. What is quick sort? Quick sort is a divide and conquer algorithm. Okay, get it. It picks an element as pivot and partition the given array around the picked pivot. There are many different versions of quicksort that pick pivot in different ways. Always always pick the first element as pivot, and second one always pick the last element as pivot. Third one pick a random element as pivot, and fourth pick median as a pivot. Okay, there is the key process. The key process is in quicksort is partition. मीन्स हमारे क्विकसॉर्ट में जो की प्रोसेस रहती है वो पार्टीशन का काम करती है. ओके, उसे हम पार्टीशन बोलते हैं. ओके, नाउ नेक्स्ट, डिस्क्रिप्शन ऑफ क्विकसॉर्ट. एज वी नो, क्विकसॉर्ट लाइक मर्ज सॉर्ट apply the divide and conquer paradigm introduction. Here's the 3-step divide and conquer process for sorting a typical sub array A of P R. Okay, now here's the divide, conquer and combine. You can see divide, conquer and combine. Okay, partition means rearrange the subarray A P R into two possibly empty subarray A of P Q minus 1 and A of q plus 1 are such that each element of a of p q minus 1 is less than or equal to a of q, which is in turn less than or equal to each element of a of q plus 1 are. Compare the index q as part of this partitioning procedure. Okay, in concur method, sort the two subarrays a of p q minus 1 and a of q plus 1 r. इन कॉन्कर में हम दो सब एरेज को सॉर्ट करेंगे, ठीक है, बाय रिकर्सिव कॉल्स टू क्विक सॉर्ट. ओके, कंबाइन में देखेंगे, बिकॉज द सब एरेज आर ऑलरेडी सॉर्टेड, नो वर्क इज नीडेड टू कंबाइन देम, द एंटायर एरे ए ऑफ पी आर इज नाउ सॉर्टेड. ओके, नाउ नेक्स्ट स्लाइड. The following procedure implements quicksort. Here is the procedure to implement the quicksort. Now you can see the quicksort a comma p comma r. If we apply the if condition, if p is less than r, then q is equals to partition a comma p comma r, and then quicksort a comma p comma minus 1, a comma p comma q minus 1, and the fourth one quicksort a comma q plus 1 comma r. The sort an entire array a. The initial call is quicksort a comma 1 comma a dot length. Okay, a dot length, we find the length of a. Here is the command a dot length. Okay, now partitioning the array. The key to the algorithm is the partition procedure, which rearranges the sub array a of p r in place. Okay, पार्टीशन करेंगे हम एरे का, ठीक है, पार्टीशन ए कोमा पी कोमा आर. यू कैन सी द पार्टीशन ऑफ एन एरे. ओके, राइट. We apply the for loop and if condition. Here we must focus on 3 to 6 line. Okay, we see on next slide. Okay, partition, always select an element x is equals to a of r as a pivot element around which to partition the sub array a of p r. Okay, as the procedure runs, it partitions the array into 4 possibly empty regions. As the start of each iteration of the for loop in lines 3 to 6, the region at the start of each iteration of the for loop in lines 3 to 6, the regions satisfy the certain properties. Okay, now we state these properties as a loop invariant. Okay, at the beginning of each iteration of the loop of lines 3 to 6 for any array index k. Now here's the 3 and 6. Okay, for j is equals to p to r minus 1. If a of j is less than or equal to x, then I is equals to I plus 1. Exchange a of I with a of j. a of I को हम exchange करेंगे a of j से. Now exchange a of I plus 1 with a of r. अब a of I plus 1 को exchange करेंगे a of r से, then return I plus 1, return करा देंगे value I plus 1. Okay, now you can see here, if p is less than and equal to k and k is less than or equal to I, then a of k is less than and equal to x. Okay, now second, if I plus 1 is less than and equal to k and k is less than and equal to j minus 1, then a of k is greater than x. Okay, if k is equals to r, then a of k is equals to x. Now you can see the iteration. Okay, now here's the complexity of quicksort. The complexity of quicksort, if you know the complexity of quicksort, how to find it, you can find it. Okay, here's the time complexity of quicksort, order of n into log of n, and here's the space complexity of quicksort, order of space complexity of quicksort is order of n. Okay, now here's the wind up. Thank you so much for watching this.